Part B of question 5, uh, I'm going to find all the features. I'm going to study this rational function here. Now, remember that to do so, I need both the factored form and the distributed form. So I already found in question in part A the both the factored form, and I have the distributed form. So the first task that I would have to do is eventually distribute this denominator, which is given to me in factored form. So here you do the best you can, and it depends how you function. I'm first going to distribute this. I would have x cubed plus x squared in there. And then I am going to FOIL these two binomials. I will have x squared plus x minus 12. And finally, I am going to distribute first the x cubed. I will have x to the fifth plus x to the fourth minus 12x cubed. Then I'm going to distribute the x squared. I will have x to the fourth plus x cubed and minus 12x squared. And I'm going to combine like terms, x to the fifth plus 2x to the fourth minus 11x cubed minus 12x squared. Now, to properly study g of x, I'm going to write it down both in factored form. Let me start with that. So for f of x, I found 3 times x squared minus x plus 1 times x plus 1 times x minus 2 times x plus 2 times the x minus 1/3. And this I will divide by the denominator given, x squared times x plus 1 times x plus 4 times x minus 3. And the distributed form would be, so for f of x, it's given to me 3x to the sixth minus x to the fifth minus 12x to the fourth plus 7x cubed minus x squared minus 12x plus 4 divided by this distributed form that I came up with, x to the fifth plus 2x to the fourth minus 11x cubed minus 12x squared. Now, this is what I'm going to work on. The first thing to try to find, if there is one, is the removable discontinuity. So in that case, so you need to spot any factor which is common to both the numerator and denominator. Here I've got x plus 1, so the removable discontinuity, the whole, would be at x equals negative 1. And to find the corresponding y, I'm just going to plug in negative 1 for x. So I would have the 3 times negative 1 squared, which is positive 1, minus negative 1 is positive 1. I'm going to skip the repeated factor here, x plus 1. So I'll have negative 1 minus 2 times negative 1 plus 2 times negative 1 minus 1/3. And at the bottom, I will have negative 1 squared, which is 1. I'm going to skip again the x plus 1, and I will have negative 1 plus 4 and negative 1 minus 3. All right. So here, to facilitate my calculus, this is positive 3, and this is positive 3. They cancel out. This is 1 and this is 1. I can disregard. There is something else to facilitate the calculation that I'm going to do, is that I'm going to distribute the 3 into there. That will eliminate this fraction here. So I will have negative 1 minus 2 is negative 3. If I distribute, I will have negative 3 minus 1, which is negative 4. And this is exactly what I have here. So those two will cancel, and I will end up having the y-coordinate of the removable discontinuity at negative 3. Then I'm going to go for the vertical asymptote. I'm still going to refer to the factored form, and I've got 1, 2, 3 factors left. I'm going to disregard x plus 1 since it is also a factor of the numerator. And the vertical asymptote would be x equals 0, x equals negative 4, and x equals positive 3. Now, the next step is to take care of the horizontal or slant asymptote, if any. So in that, for that, I'm going to refer to the distributed form this time. And the first thing I need to be aware of is the degree. The degree m on top is 6, the degree n is 5, and in that case scenario, I will have a slant asymptote, which means that I will have to perform a long division. So I'm going to divide by x to the 5th plus 2x to the 4th minus 11x cubed minus 12x squared, the following: 3x to the 6th minus x to the 5th minus 12x to the 4th plus 7x cubed minus x squared minus 12x plus 4. I'm going to divide leading terms to find the first term of my quotient. 3x to the 6th divided by x to the 5th is 3x. I'm going to distribute back, and I will have 3x to the 6th plus 6x to the 5th minus 33x to the 4th minus 36x to the 3rd. I subtract, and I will have negative 7. And I would have positive 21 x to the 4th. And here I would have plus 43x cubed. I would, of course, bring down all the rest. My remainder has an equal degree, so I'm going to keep going. It's going to be -7, and I distribute back. I'll have -7 to the fifth minus 14 x to the fourth plus 77 x cubed plus 84 x squared. I'm going to subtract, and I'm going to have 35x to the fourth negative 34 x cubed and negative 85 x squared. I bring down the rest, and here, because the degree of my remainder is less than the degree of the denominator, I stop. And I conclude that the vertical asymptote, slant asymptote, is y equals 3x minus 7. For the y-intercept, in that case, I just need to evaluate g of 0, right? But the because of this factor, x squared, 0 is not part of the domain. Instead, that was a vertical asymptote. That is a line that the graph is not going to even touch. So there is none in that case. But for the x-intercept otherwise, as long as x is not equal to 1, remember that it would otherwise, -1, my bad, basically f of x can be equal to 0, right? So I've got the factored form, and I can directly conclude that based on the factors, it's going to be -2, 0, 1/3, 0, and finally 2, 0. And that's it. Good luck.